Good afternoon. This session is about building a cross-platform OS deployment solution with PowerShell. We know who our sponsors are. We've talked a little bit about who I am, but at least in this particular context, we're jumping between two of these line items. Back when I was at Microsoft, I built a solution called MDT. Who knows MDT? Oh, that's a good one. And as part of that, we had adopted PowerShell for the administrative side of things. Now, years later, we are re-implementing that at 2Pint as a new solution using PowerShell on the other end. So using it for the client-side processes rather than the administrative side processes. We'll talk about the reasoning behind that, but I figured it's useful to kind of start off with how did this whole thing start? I started working at Microsoft in 2004, moved to Redmond in 2005. 2006, sitting in an office, I get a random meeting request from this guy I've never heard of called Jeffrey Snover. He wants to talk. Fine, whatever. I'll take a meeting from a random person to see what they want to tell me about. So he came in, and as would be typical, he would get on the whiteboard and start drawing things out. Here's what I'm building, Monad, it does all these things, and you can use it in this way and that way. And by the time he was finished with his 45-minute conversation, we said, yeah, good timing, because we're building an admin tool for a new product, and we need to base it on something. So we decided at that point that we could use a PowerShell backend through a C# interface to an MMC snap-in. Seemed like a good idea at the time. So we started down that path. So we do have a managed MMC snap-in written in C#. We're not sure that there are any of those left in Microsoft anymore, but this one still is alive and kicking. Apparently, managed code inside of an MMC is a little flaky, as we discovered along the way, but it is what it is. We decided at the time it would be useful to implement a drive provider for doing that. Who's written a drive provider? Oh, no. That was a bit of a nightmare because at that point, as you can guess, there weren't many examples to look at. There wasn't any documentation. We were kind of learning this as we went along. We brought in some contractor developers who were ex-Microsoft SDEs and had them start working on it, and both of them quit. They said, I just can't figure this stuff out. So I ended up writing most of it. It, at one point, was over 50% of the code in MDT, just in a PowerShell provider. Now, over time, I don't think it ended up being that way, but it's still probably a third of the entire code base. Now, on the client side, we couldn't do PowerShell. We had to do VBScript because we didn't want to have to deploy .NET and PowerShell 5, or whatever the current version was at that point, out to the machines, just to then wipe the machine and lay down a new operating system image. So we went with VBScript on the client side. A number of years later, we went back in and said, well, we should add better PowerShell support to that. So we added a PowerShell host and a couple of drive providers, which we'll take a look at. And started probably in 2013 or so, a long effort to convert all of that VBScript over to PowerShell. That's still going on today. It's a never-ending process to do that. So if we start off with that particular picture, we can go over to a virtual machine where I have a copy of Debug View running. I can run MDT from there. So if I launch Deployment Workbench, we see a couple of deployment chairs, and within them we have apps and operating systems and drivers and all that stuff. But you can see references in here to run spaces and the number of items that was retrieved and some drive references. These are all PowerShell code. All the debugging logic, we never bothered to strip it out. We just left it in there so that we could see what was going on. But all of this had to be completely asynchronous so that you could do things like keep clicking around the console and actually have it somewhat responsive, because while one thing was still filling out the page, you might click on something else, and now we needed to be able to fill that out as well. But that was what was going on behind the scenes. Now, that was what most people saw. What most people didn't see was the back end, the PowerShell provider itself. One of these days, I'm going to figure out how to fix this particular problem with Terminal. There is a WSL profile that doesn't have an icon, so it errors out all the time. But ignoring that, we can go into our PowerShell session, navigate to Program Files, Microsoft Deployment Toolkit, bin, and then import module Microsoft Deployment Toolkit. And guess what? It doesn't work on PowerShell 7. Not a big surprise. I think that would be fixable. It just doesn't have the necessary libraries for that version, but okay, we'll have to go to 5.1. Not the end of the world. Okay, so here we can import the module. Now, if we look in the actual MMC, we can see that there are 2 deployment chairs here. We don't yet have those, but we can restore them. So there's a commandlet to do that. Restore MDT persistent drive. Now we have 2 drives that point to those deployment chairs, and we can do things like do a directory on them. So if we do a directory on DS001, we see the same basic layout that was in the MMC. Oops. So if I type in to get a directory of applications, no big surprise. It looks exactly the same as what we would get if we clicked on the applications there. Now, if we look at the properties, we can see that not only are these composed of metadata, but also content. So we can see the content size of these in here somewhere. But basically, we had to keep track of those as kind of an entity, a unit that is even copyable. So like if we look at today, we've got 3 applications in this deployment chair. In the other one, I don't currently have any applications. Okay, well, in theory, I should be able to do a copy. From one to the other. Did it work? Nope. I didn't get the syntax right there. Oh, yeah, I did. Just didn't refresh it properly. So yeah, we can copy everything, and that copied not only the metadata, but also the content that went along with it. So it made replication from one server to another and backup and restore scenarios and all kinds of things interesting. We also had the ability then to import content, and not surprisingly, importing content would be using PowerShell as well. So like if I were to go to out-of-box drivers, I could say I want to import drivers and specify some reasonable driver folder. How many input drivers can there possibly be? For one model of machine, we'll go ahead and import those. And at the time, there was one other product, Exchange, that was doing something similar, and we saw in Exchange, oh, they had a view script button. So that View Script button would show you the equivalent PowerShell script that you could run. We didn't realize until like 2-3 years later, we did it backwards. If you think about Exchange, if you ever saw what it did, it would say you'd go through the wizard, you would choose what you wanted. It would show you the script, and then you would say execute it. So you could copy the script and run it manually instead of having to actually run it and then copy the script for what you had just run. Oops. Someone should have pointed that out at the time, but it works out okay. So the equivalent, obviously, is this import MDT driver commandlet. We've got a bunch of commandlets to do imports, but otherwise it's just a file system provider that is a navigation provider and a content provider and everything else that maintains the details. Now, the next piece that we added was to manage state across task sequences. We maintain a list of variables. So basically they're name value pairs. They had to survive reboots and all that kind of stuff. They work in Windows PE and into the full OS and etc. from there. So when we added PowerShell support to do that, we needed to, where's that other one? Let's go over to E. Deployment share, tools, modules. We needed to create another module. And that module implements 2 additional drives. So if we do dir tsenv, all right, nothing there. Tsenv list, nothing there. But we can set a variable just like we would set an environment variable. It helps if I can type. All right, so we now have a variable there, and that would get persisted through the whole process. We could also do tsenv list. For arrays, we could specify that equals something like that. And if we do a directory on the tsenv list, we now see one item with an array. But if we go back and do a directory on the first one, that array is actually just a list of variables because we didn't have the ability to do arrays. We only had the ability to do individual name value pairs, basically variables like environments. So that all works well, but that's really the key behind the scenes of what MDT is doing with all of that stuff. So as we move forward then, we end up with the need to do kind of the equivalent in a new solution built around PowerShell, but we can at least bring forward compatibility from this older implementation to do that as well. If we look here, we've also got a custom host. 2 of them actually, one for .NET 3.5, one for .NET 4. But you could run that instead of the PowerShell host, and instead of writing to, say, a transcript, that host would write to a file format that config manager people liked, the cmtrace file format, so that you could more easily view the logs that were being created. Almost no one used it. Most people who did their own PowerShell scripts inside of MDT never discovered that these existed because they never read the docs that talked about them, and therefore they just set up task sequence steps that ran PowerShell.exe-file and whatever file name, and they did their own transcriptions and all that good stuff. And if they needed to interact with variables, they used a COM object, Microsoft.sms.ts environment, and they never even used the drive providers that were out there. Next time around, we want to make them, so we won't provide any other option. But we might end up having to do that too. As much as I hate writing COM objects in the year 2025, we might have to do that just to make these people happy. So last year we started then working on a replacement. That replacement we call deploy R. Basically all of our product names end with an R. So it is something that needs to be compatible and familiar with people who are used to MDT and SCCM. There's also the PSD, the PowerShell deployment, that translation of all that VBScript over to PowerShell. That is an open source solution out on GitHub. I started that, I think, in 2015, and it's still going 10 years later. But that set of PowerShell scripts, we should be able to even host on top of a brand new engine that isn't dependent on anything from MDT. Obviously, we don't want to do any more MCs ever. So now let's build a web-based administration process with REST services that are driving that and move on from there. Now, PowerShell 5.1 in 2024, 2025 doesn't seem like a great idea. So we said, well, from the start, we'll do PowerShell 7, and therefore we'll use .NET 8 for all of the stuff that we're building. And we'll provide the ability to do some things in PowerShell 5.1 if you really want. So you could run, say, an out-of-process PowerShell.exe and still access those drive providers to interact with the variables because, okay, we can do those in .NET Standard, but for most things, we want to encourage you to use .NET 8. So, REST-based services, web-based administration. How many of you have seen the Azure commandlets that are generated from the Graph API, which is a very large REST-based API? What's the longest commandlet name that it's come up with? They're ridiculously long because they're basically machine generated. They're pointing a chunk of code. I always forget the name of the utility that they use, but they'll point that at a Swagger definition of all the REST calls that are available in Graph, and it'll spit out machine-generated commandlets, which are gibberish to normal people because they map like 100% back to the underlying REST calls. So we're not big fans of doing that. We instead have built custom PowerShell commandlets to do the same thing. But we're still debating, do we go back and write another drive provider and expose all of those REST commandlets in the same way that we did with MDT in the past? It gives me nightmares because that was a lot of work to add. I've seen some additional drive provider libraries and examples and helpers come and go. Seems like Microsoft has deprecated most of them because those providers never became super popular besides the ones that are built in, like registries and file systems and that kind of thing. But we may consider it at some point. But for right now, we've just manually built our own PowerShell commandlets to do the same. Client side, then, we have a .NET 8 based PowerShell 7 host that runs all the scripts in process, so we don't have to constantly start up PWSH, run a script, shut it down, run another one, because a typical task sequence that we're running could easily have 40 or 50 scripts running into it, so you spend a lot of time and start up and shut down. We've got the .NET 8, .NET Standard PowerShell drive providers so that we can support 5.1 if people really want to do it, and a bunch of PowerShell 7 modules and scripts with some 5.1 support. That gets interesting because there are some things we really like to use in PowerShell 7. So we have some modules that say they support 5 and above, but they contain commandlets that only support 7, which is not possible to do declaratively, so you had to explicitly put checks in the code to say, is this not on 7 or above? If so, throw an error. We also have challenges around Windows PE. Who's used Windows PE? If you used MBT, you've used Windows PE. It contains .NET Framework and therefore PowerShell 5.1. Okay, we don't want to use either of those. We want to use .NET 8 and PowerShell 7. So we can inject those in. There's no simple documentation or official support on how to do that, but it's not too hard to figure out how to get those into Windows PE, and they work pretty well. Now, if you've ever looked at PowerShell 7, the install folder, you probably noticed it carries a complete copy of .NET 8 in the folder. I mean, it's kind of the .NET 8 way of doing things, or all the .NET Core versions. You package up all of the dependencies that you need from the .NET Core release that you're using, and you ship them with your app. So the PowerShell 7 installer lays down the PWSH and a nearly complete set of .NET 8 runtime files in the same folder. Okay, but we don't really feel comfortable pointing our apps, which are .NET 8 based, at a shared runtime that isn't really a shared runtime. The PowerShell 7 files that are in the program files PowerShell 7 folder. So we add our own .NET 8 runtime, which ends up in program files .NET. Well, now we have two of them in Windows PE, and they're not tiny. They're a couple hundred megabytes a piece. They at least get compressed. The nice thing about a WIM file, when you create the Windows PE, they're single instanced. So as long as they're the same versions between the .NET 8 install and the PowerShell install, we only end up with one captured in the WIM. You would think that they would be identical between the two, but they're not always. It's like the PowerShell team is getting hot-fixed versions of .NET 8 that aren't publicly available because the binaries will subtly differ between the two. But okay, so some of them end up being duplicated in the resulting WIM, but it's not the end of the world overall. Then we thought, okay, we can rip out the .NET framework and PowerShell 5.1. We don't need it at all. We can just run everything PowerShell 7. Nope, can't do that, because if you don't install PowerShell 5.1, all of the default Windows PowerShell modules, which we want to use, like get disk and export archive and apply Windows image, all those sorts of things, they're just not there. So you have to include PowerShell 5.1 to get the modules that you can run then from PowerShell 7. But it pulls along all the other garbage from .NET 5.1, .NET 3.5 and PowerShell 5.1. Unavoidable. We do a little bit of whacking to reduce the space a little bit, but basically we end up with a Windows PE boot image that has .NET 8, .NET 3.5, PowerShell 7, PowerShell 5.1, and all of our stuff added on top of that. So it gets to be a little big, but okay, at least we can download it quickly. When you're running in Windows PE, the ability for PowerShell 7 to start a PowerShell 5.1 process and remote to it to run things that aren't supported in PowerShell 7, like the WMI commandlets, doesn't work. You can't do any remoting from Windows PE at all. So if you try that, they fail. All right, rip out all the get WMI object calls and replace them with get sim instance, and off you go. Most of the other things are just standard .NET 5 to .NET 7 compatibility issues, but for those things in particular where you think that you can work with these workarounds, they just don't work in Windows PE. There are some things where we'd like to do browsers inside of Windows PE. The only browser you can include is an IE11 engine, which isn't useful at all these days, so we'd like to put in an Edge web view, but one, they're too big, and two, they don't work because the browser engines, especially the one for Microsoft, has checks in it to say you can't run this as local system. Well, that's all we've got in Windows PE. There's no way to run a browser as any other user. We haven't given up yet. We can create local users in Windows PE and start a process as that local user in Windows PE, but the UI that we end up getting from that browser is transparent. it's there. We can click on it. We know it's doing stuff, but we can't see it. All right. I haven't given up yet, but we'll keep working on it. We've also experienced a lot of joy around the PS module path. We have our own custom host. And as a custom host, if you're familiar with the module path behavior with PowerShell 7, basically it's taking the PS module path environment variable from PowerShell 5.1 and modifying it and inserting some PowerShell 7 directories at the beginning of it. When you're running your own custom host, it adds directories to the beginning of it, but they're relative to where your host binary is, not to where PowerShell 7 is installed. So we had to modify the path to put in the normal PowerShell directories so that we can run normal built-in commandlets as well. So lots of manipulations that we had to go through for that. We still had to deal with LTS versus non-LTS releases. Most of our customers prefer LTS releases. We're not too crazy either way. We don't care. We do recommend that most of the customers set the update check environment variable to at least avoid the prompts if you only want to see LTS updates. All right, so let's switch over and look at that side of things. First, starting with the web interface. Basically, everything that we have is exposed through web interface, so we can see our task sequences. If we drill into one of those task sequences, like to install Windows OS, it's very similar to what you would have seen in MDT in the past. We can format the disk, we can apply an operating system, we choose the OS, the index, all that good stuff. But all of this in the end turns into the equivalent of what an MDT task sequence was and just executes one step at a time. Now we can have explicit run PowerShell scripts in here, like that's a super trivial one that just writes hello world, or a lot of these behind the scenes implicitly run PowerShell. Like this apply OS step is actually defined here so that when someone does an apply OS, what they're actually doing is running a script named apply.ps1, and that is contained in a content item that we've uploaded to our server. Okay, so what is that content item? Web server imports content items. So like the apply.ps1 script that I was just talking about just will echo out its name, import our standard modules, get some information about the other variables that have been configured in the task sequence, and go about its thing. So basically, there is a one-liner in here that applies the image, expand Windows image, that applies the WIM. All the rest of the stuff is just figuring out, all right, where do we put an unattend and how do we want to continue the task sequence in the new OS, because there are so many options. And we basically said, well, we don't know which one to support, so we'll support all of them. So a bunch of scripts that get fed into the process that drive things overall. Now, if we look at the next piece, we had to be able to generate those Windows PE images, so we use PowerShell to do that. This one, yeah, it will run on PowerShell 5, but the basic idea is that we can generate a Windows PE image in two phases. One of them takes a long time. That long time process will take a Windows PE WIM from the 80K or one that you've provided. It will mount that, inject a bunch of optional features into it. It's in here somewhere. Let me scroll up. So we'll add optional features to it for all the things that we require, including WMI and .NET Framework and PowerShell 5.1, etc. We'll turn off some things because if you used a Windows RE feature, there's stuff that we don't really need. So we'll turn that off. We'll then mount registry hives and create entries for PowerShell. We'll add PowerShell and .NET to the path. We'll create profile folders so that PowerShell Get actually works from within Windows PE. Otherwise, it fails very miserably. The whacking logic that we had to try to reduce things, we at least were able to add some logic to, man, I keep clicking in the wrong place. We could at least clean out the PowerShell 5.1 binaries, but we couldn't do much else beyond that. The second phase then is a lot faster. So we take that initial WIM that we've customized and added PowerShell and .NET and other stuff into, store that off to the side, and then we can do a quicker modification to just mount that one again, put our binaries and config files in it, write it back again, and make that available as a bootable file. So lots of PowerShell going on there. If we were to then look at a client machine, let's look at this one. This one is already booted into Windows PE. So if we look here, we've got a minimized PowerShell session running PowerShell 7.4.11. I updated this last night. It's all current. We can do things like install module, which I did yesterday, UEFI v2, and this time I know to specify skip the publisher check so it doesn't fail the first time. So we have full access to install things from anywhere. Works pretty well. But if we were to run an actual task sequence, let me pick one. It's not the ones I want. You gotta love UIs where there are hidden buttons, but click the hidden button, it shows hidden things. But I can find my demo task sequence then and start that, and it will run a task sequence. In this case, this demo task sequence just has 3 steps. The first step uses a PowerShell script that does write progress. So it counts from 1 to 100 and updates the progress. So you can see we've integrated progress reporting. The second step in the task sequence contains 1 line. And let's look at what that 1 line is, because we worked on that yesterday. That 1 line basically just says, wait for a debugger. So the task sequence that I'm running is this one. It's just a wait debugger call, and we catch that in our client-side execution engine so that that client-side execution engine can then pause the execution until we continue. Now, at some point, our intention is to add a full client-side debugger to let you single step through scripts and through task sequence steps and all that good stuff. But at least for right now, I can look at the log and see what's happened up to this point. We can say, yeah, we're currently paused in a temporary script name that's been written with the script that we're executing. Great. And I can click continue to go on from there. Obviously, this one is counting backwards, but basically same idea. We're just running PowerShell scripts in the series and making them modular so that we don't have one giant script that we're trying to run to do this whole process, but instead just have a bunch of very small scripts that do the actual work. So when it comes then to cross-platform, we said, well, while we're at it, all the code is written on .NET 8. All the PowerShell is using PowerShell 7. We should deploy other OSs while we're at it. Now, we can't deploy Mac OS because Apple makes that pretty much impossible these days, but we can deploy Linux. We can deploy Chrome OS Flex. There are other operating systems that we can throw into the mix. In order for that to work, we need a Linux boot image. So what we'll do is use PowerShell to call WSL where we have a Fedora image that can use Live CD Creator to generate a basically a Linux boot image, a Windows PE equivalent. We can boot into that Linux image and do the exact same thing that we were looking at before. So we have the UI pieces are written in Avalonia. Avalonia is a cross-platform UI. It runs fine in Windows PE, on the full OS, in Linux, on Mac OS, everywhere else. But all the rest of the code is exactly the same between the two. So if we switch over to a different client, this one's booted into Linux. Can you tell the difference? Not really. The biggest difference is there's no title bar on the window in Linux, and there's no minimized shell, just because I haven't added the code to do that yet. But from here, we could run a task sequence to do something like deploy Chrome OS Flex. Now, deploying Chrome OS Flex is basically a single-step process, and it won't work on Hyper-V because Flex doesn't include a driver for the Hyper-V disk. So it's funny because as soon as it reboots into the new OS, it basically just hangs. But at least the nuts and bolts, we can see it downloading the files and applying them to the disk. Now, if we were to look at that task sequence, which is back over here, we can see how simple it really is. Chrome OS Flex contains one step, apply Chrome OS Flex, that points to an image. That image is basically the downloaded zip file of a disk image that Google makes available. And then a second step that basically says, when this task sequence finishes, reboot the computer. If we look inside of that Chrome OS Flex step, we can see that it's running a script called apply Chrome OS Flex. If we look at that script, it doesn't look much like any typical PowerShell script because there's just no modules available in Linux that do anything useful along these lines. Yes, there are the built-in PowerShell 7 commandlets, but there's no operating system commandlets. So to format a disk, we can't use PowerShell to do that. We're basically just using PowerShell to launch commands. To make matters worse, most Linux-based OSs, Chrome OS Flex included, their imaging formats are what I would call destructive file formats in that they completely overlay the partition. So how would you download a file to the machine and then once it's downloaded, apply it to the disk in question? You either have to stream it and apply it as you're streaming it, which is really tricky for some of these file formats. Like a WIM file has the metadata at the end and the data is at the beginning, so you can't stream, you can't pipe a download like that. Or alternatively, you had to download it into some other location for safekeeping while you apply it to the disk. Fortunately, in the case of Chrome OS Flex, it's small enough that we can create a RAM disk. Let's create a 4 gig RAM disk on a virtual machine, download, it's basically like a 2.5 gig image into that RAM disk. After it's downloaded into that RAM disk, we can then tell gzip to decompress it and feed the decompressed result into DD, which is basically just a binary writer that takes every block and writes it to the disk that we specify. So it ends up being a super simple process, but like if we wanted to figure out which disk are we applying it to, fortunately, there is a built-in command in Linux called lsblk that has a -- JSON option that will spit out JSON, and we can then manipulate that with PowerShell, but there's no command to do get disk like there is on Windows. So we're going to have to build out a lot of that as we get deeper into this. While we're here, the process for building that Linux image, basically we had to download a starting point, so we can download from Fedora the source files that we need as a starting point. We can install WSL if it's not already installed. We can create a new WSL entry, basically a container, by importing what we had just downloaded. We can then add the necessary things to that. Most importantly, the utilities that we need to customize it. Basically, it's the live CD tools and the dependencies that it has. And once those are down there, eventually we get to a point where we can tell WSL to run a shell script. Now, could we eventually install PowerShell 7 in the WSL container and then transfer to that one? Yes, but for right now, the shell script is super simple, so we didn't convert it over to PowerShell yet. Let's see if our image is rebooted. It probably has already. Yeah, it's still working on applying it. The decompression process is rather slow. Writing it to disk is quick enough, but that 2.5 gig file download ends up getting expanded to like a 10 gig disk image because it's basically writing every sector to the disk, and there's a lot of binary 0 sectors in there, so it does take a while, but it's definitely why you want to keep it zipped and not unzip it and download it, because there's no way you could get enough RAM to hold the decompressed file. So we've got that. The next step for us then is to figure out how to do real operating systems, or at least more comprehensive operating systems, because things like Red Hat and Ubuntu and all the other OSes have dozens of different ways that they can be configured. They use different file systems, they use different disk layouts. If you're someone who really likes the B-tree file system, oh man, that one's really nasty. Figuring out how to deploy that one is very interesting. But we're working our way through those to figure out what to do, how to most easily do those. But for the most part, it requires what I call partition swapping. So we have to create the partition structure that's required, tag one of those partitions as kind of temporary storage, download the content that we need into that temporary storage location, use it from that location to apply it to the other partitions, then copy that temporary storage into one of the restored partitions, and then move to that partition and use it to apply back to the original temporary partition. Messy, but it works. It's just doing that in a generalized way to support all of these different file systems and all these different distributions is a major headache, but we'll get it worked out. So we have all kinds of challenges. We have no usable PowerShell modules, no WMI, no hardware information, no disk partition information. There are ways to come up with some of this, but they're all basically running either command line utilities that are built into Linux or reading information from file systems. Linux has an interesting file system that contains SMBIOS information and DMI information, and you can read the files from that file system to find the manufacturer, the model, the serial number, the asset tag, all that good stuff out of the firmware of the device. But you just have to build that out yourself. So we've debated, do we just bite the bullet and build a get computer system info commandlet ourselves that does the same thing as the Windows one and make our life easy? Or do we just not worry about it and do less work? So we're still working on that one. File systems and disk layouts and the destructive imaging I already talked about. There's also fun around case sensitivity. Windows isn't case sensitive, Linux is. So writing code in .NET 8 that you intend to work on both, you better be consistent on your case of the files that you put in place. So we're very specific on the directory names that we create. For things that we pre-populate in our boot images, they're always first letter uppercase. For things that are created on the fly, for like logs and content storage and that kind of thing, they're always lowercase, so we can tell the difference between the two. But occasionally we screw it up and then wonder, it's right there. Why isn't it working? Like, oh, yeah, it's case sensitive. Got burned by another small one last week. Why is the module path not working? Well, on Windows, how do you separate entries in the module path? Semicolons. How do you do it on Linux? Colons. Oh, man. So you had to go through and change the logic to use a different separator when we're building out the module path on Linux. We've already done the demos. We do have a wish list in the probably 30 seconds that I have left. We really would like to have the PowerShell commandlets from 5.1, or really from Windows, separate from 5.1 so that we could install those separately. We would really like a easier Windows PE process that is supported. We'd like Linux to provide more commandlets that are actually useful. We may do our own navigation provider again to expose all this stuff as a drive in PowerShell. And we'd really like a working browser in Windows PE because of things that require authentication. They tend to want to throw up a browser window to do that. And without the browser window, you can't do authentication without some type of device auth process that goes off of the machine. All right. Any questions? If not, thanks a lot for attending. Since I think there's another person coming into here shortly, just track me down after the session or tomorrow or whenever. But thanks a lot.